That's it. So, well, let me make a little introduction. I am Juan Ospina, bacteriologist, PhD in biotechnology. I've been interested in Aptámeros for about 8 years now, specifically for diagnosis of tropical diseases. I'm currently writing a book about Aptámeros, and that is why I am here today together with Larry, because he's a pioneer in the development of the SELEX strategy as a professor at the University of Colorado at Boulder. He's a member of the American Academy of Arts and Sciences and the National Academy of Sciences in the United States. Larry has received multiple awards for his work, such as the National Institute of Health Merit Award, the Career Development Award, the Lifetime Achievement Award from the Colorado Biosciences Association, among others. So in the next space, I would like to ask you some questions. The first question is, what do you think were the key background elements that allowed the discovery of SELEX strategy?
In his PhD, which was to find a messenger RNA that was translationally regulated, meaning that when the protein level built up high enough, it bound to its own messenger RNA and blocked its translation. And he was finishing his PhD. He'd done all this work. He had written papers. He was great. Is still great. He's still my friend. And he sat with me and we looked at the RNA to which this protein bound. And there was a part of the RNA that was a little 5' to where the ribosome had to bind. And he said, I want to study mutations in this hairpin that was just 5' to where the ribosome had to fit. And so we talked about it. And he was going to order some single nucleotide changes, because you could buy things then as now. And in the course of our conversation, I said, Craig, no matter how many changes you make 5' to the ribosome binding site, somebody on your committee will want you to do more, because that's what committees do to graduate students. They think they're being smart by suggesting that you do more work. So why don't you do all the sequences at once? Do them all. This was a very narrow effort, a narrow experiment. And he said, well, what do you mean? And I said, well, take the 8 nucleotides on the loop of the hairpin. That's 5' to the ribosome binding site. And why don't you do 4 to the 8th sequences, 65,000 sequences instead of a few? And to his credit, he said, of course, let's do that. I mean, he was great. And then he did all the work. He worked for almost 2 years to do that work, the first SELEX experiment. And then, again, without talking to me, just so you're clear, I was his advisor, but he was such a good experimental scientist, he did not need my help. I was a good experimental scientist, but all the work was his. And except for that one conversation in my office, we didn't talk about it until the Wednesday night before Thanksgiving in 1989. So 2 years with a graduate student in your lab working very hard and no help from me, zero. Just because it's what you want. You want independent people in your life, and Craig Turk was an amazingly independent man. So then he got the results that were published eventually in a PNAS paper, the science paper, but before it was published, he had the gels and the data, and we looked at it together. He said, "You're not going to believe this." This is memory. It's 30 years ago. So, and it's a wonderful moment, really. So, and we looked at what he got, and what he got were 2 sequences out of the 65,000. And one had only 8 letters in the loop, and he got back the wild type. That doesn't happen very often in biology. It's almost never true that a selects experiment for a nucleic acid binding protein gives you back the biological solution, because all selects does is look for best binding, and not function of any kind. You don't know where the KD should be. And then he got a second sequence with 4 mutations in those 8 nucleotides, which I know you read. And in biology, genetics, I was trained as a geneticist, you cannot get in any selection you would do in a real piece of genetics, you cannot get 4 mutations over 8 nucleotides. Never. You would have to wait 1 trillion years for that to happen. And he got a thing that made no sense to us. We now know it does because somebody did the structure of the fascinating. And so the second sequence, 4 mutations over 8 nucleotides, was really a structural homologue of the wild type. And it's never been found in biology because you can't find, we didn't know that. So there we are staring at these 2 sequences. And together, I don't know which of us said it first, to be honest. It probably was Craig, but I don't really remember. He said, "Wow, you can make antibodies out of RNA because you can make things that bind to anything, like antibodies." And we looked at each other, almost hugging. We weren't hugging. He was a big man, and I'm not. I'm small.
Yeah, the next question is, at that Eureka moment, what were your initial thoughts that you had something very valuable in your hands?
Because we were living it. So I went home. This is the Wednesday night before Thanksgiving, a big American holiday, U.S. holiday, on Thursdays. And the Thursday of 1989, the night before, I went home. I was all like that. And I started to write what became the patent based on the whiteboard that Craig and I had written all over. We didn't have cell phones. I didn't then. So I had to remember what we'd written down. We didn't write anything down. We just left it out all weekend. And I started by that Wednesday night writing and staying up all night. I did that a lot in my life, and just type it away. And that afternoon, my family and I went to a friend's house for Thanksgiving dinner. and I'd already written a draft of this patent by staying up all night, which we then worked on some more. And I fell asleep because I hadn't slept all night on the floor next to the Thanksgiving dinner table. And everybody said, he does this all the time. There's something on his mind. They just walked over me. They didn't bother to wake me up. So I slept through the big turkey that is the traditional Thanksgiving dinner. On Monday, I now had a draft to share with Craig. It took us 8 months to submit this patent. We worked on it very hard. And on Monday, 3 days after the Wednesday discussion, there was a very nice postdoc in my lab. Again, still a friend, lives in Colorado, who had, it was his turn to give a lab talk. And he gave a lab talk, and I know this is being recorded, and I loved my lab. There were 20 people in it. They did their own stuff, and Peter was talking about his stuff. And I was sitting there thinking, I don't care about this anymore at all. It no longer, it had been the most important science thing in my life, all of it. And I lost all interest in what everyone in my lab was doing except Craig. And it took 3 days. I'm a transparent person, I think, mostly. And we finished the lab meeting, everybody's going back to work, and I said, hey guys, come on back. So they came back and said, now this is all true, and there's no exaggeration here. I'm capable of lying, but this is not lying. I mean, I'm capable of exaggerating. And I said, hey guys, this thing that's on the board out there is what Craig has done for the last 2 years. And I've spent the last 4 days, 4 days, completely in love with what he did. And I think it is really important. I think. I don't know that, but I think so. And what I'd like all of you to do, I said, after 4 days of thinking about it and writing this draft of the patent, I want you to go back to the lab and throw out, and these are my words exactly, and I've asked people who were there, because we're all friends still. I hope, I want you to go back to the lab and throw out everything you have in the cold room and in the fridges and in the freezers. Just throw it all out. And then take your notebooks and throw them out. And then we'll meet later. I'll take us all out to dinner or something, sit and talk about how we can all help Craig turn this into something great. And one of the people in my lab at the time is very famous. He's more famous than I am. He's the guy named Sean Eddy, E-D-D-Y, who was a computer scientist and an experimental scientist, and now is a professor at Harvard doing both wet chemistry and computational stuff. And he, as I was carrying on about throw everything out, he raised his hand and he said, I'm supposed to defend my thesis in 2 weeks. Is it okay if I finish my thesis and maybe join you after I do my PhD, since I only have 2 weeks to go? And I said, I forgot about that. So sure, I don't care when you all do it. And in fact, it should be voluntary. Maybe some of you, I just heard Peter give a good talk about what he was working on, and some of you will be touched by what you're doing, and you shouldn't throw your stuff out. You should do what you want. But it's my judgment that this is going to be huge. And we got lucky. So let me tell you what I mean about getting lucky. May I do that for a minute? Just to tell you, bewilderingly different. And that was the real source of the invention. The invention could have been made without Craig's experiment. He could have said, just put a lot of RNAs in a tube and select what you want. I'm going to say it that way, not a big deal. But at the time, the kind of idea about what was possible from a folded RNA molecule back then in 1989 was not what it is today. We now know so much more about folded RNAs. In fact, I used to give talks in the early days of tapes versus shapes. And because all of a sudden, RNAs were a world of shapes, not tapes. And then I got cute, and I would say, well, strings versus things, the same idea. And I thought that was cute, and I gave talks like that. And as did Craig. I mean, Craig got to be well known. And so really the breakthrough emotionally was that you got this very strange creature, the second molecule, which was the first aptamer. We didn't call them aptamers, remember. That came from my friend Jack Shostak and his postdoc Andy Ellington, who had done a similar experiment. It wasn't an experiment quite as elegant as Craig's, but Craig had the advantage of having worked on this bacteriophage T4 DNA polymerase for 4 years. And so he knew this molecule, so he wasn't going to do what Andy Ellington or Jack Shostak. I know Jack Shostak very well. He's a dear, dear friend. And his interest in having Andy do what Andy did was really connected to his deep need to understand how you could get from the RNA world to life.
I love
That's Jack. That's Jack, okay? That he's driven to do that. And he's been doing that since that day that he and Andy did their experiment. It was published a month either later or before, I can't remember, but they were the same time. I think theirs was a month after Craig's paper. And then Jack didn't think about the diagnostics and therapeutics the way I did, because I was kind of interested in that. But his interest in how biology starts is deep. He could not be shaken from that. Andy's interest was not that. And Andy continued to be an aptamer guy in Texas. But Jack, in fact, you could look up, it doesn't matter, you could look up a talk that Jack gave a year ago at a symposium that I organize every year. And you can look it up on the web. It's Gold Lab Foundation, all one word, Gold Lab Foundation,